The functions f of x equals the log of x, g of x equals the logarithm of x minus 1, and h of x equals the logarithm of x minus 2 are graphed below. A. Match each function with its graph. Let's use our calculator to help us. First of all, let's sketch a graph of f of x is equal to the logarithm of x. On our calculator, we first of all go to y equals and we enter the logarithm of x. Next, we create a good viewing window. So we press Window, and then we use the scale that's provided on our graph to help us determine the settings. Our x values along the x-axis range from -1 to 5 with an increment of 1. So we enter -1 for x minimum, 5 for x maximum, and 1 for the x scale. Along the y-axis, our values range from -2 to 1 with an increment of 1. So we enter -2 for y minimum, 1 for y maximum, and a scale of 1. Next, we go to graph. And we see that the graph of f matches graph A. So f of x equals the log of x corresponds with graph A. For g of x equals the logarithm of x minus 1, we go back to y equals, and we enter the logarithm of x minus 1 for y2. Press graph, and we notice that the graph of g corresponds with graph B. For h of x equals the logarithm of x minus 2, we go back to y equals, and we enter the logarithm of x minus 2 for y3. When we graph this function, we see that its graph matches graph C. For part B, we're asked to find the value of x for each function that makes that function equal to 0. To determine the value of x symbolically, we would substitute 0 for f of x, 0 for g of x, and 0 for h of x. For f of x equals the logarithm of x, we would first of all substitute 0 for f of x. So we need to solve the equation 0 is equal to the logarithm of x. Well, if we recall that a logarithm is a power of 10, then that tells us that x is equal to 10 raised to the 0 power, which is 1. And we can look at the graph also and see that the graph of f, or graph A, crosses the x-axis at 1, 0. That tells us that 1 is the value of x that makes that function equal to 0. So x is equal to 10 to the 0, which is the number 1. For g of x, we'd use a similar strategy. We would substitute 0 for g of x. To solve this equation, we exponentiate both sides base 10. So on the left-hand side, we get 10 to the 0. And on the right-hand side, the exponentiation base 10 undoes the logarithm base 10, just leaving us with x minus 1. So we get 1 is equal to x minus 1. Adding 1 to both sides gives us x is equal to the number 2. Notice again that this value of x corresponds with the x-intercept. The graph of g crosses the x-axis at x equals 2, so x equals 2 is the value of x that makes that function equal to 0. To find the value of x that makes h of x equal to 0, we use the same strategy. Substitute 0 for h of x, and then solve for x. We first of all exponentiate both sides base 10. 10 to the 0 is 1, so we get 1 equals x minus 2. Add 2 to both sides and we get x is equal to 3. Notice that 3 is the x-intercept of h. So 3 is the value of x that makes h of x equal to 0. For part C, we're asked to identify the x-intercept for each function. To find an x-intercept, we determine the value of x when the function is equal to 0. Well, we've already done that in part B, so we can visually see that for f, the x-intercept is 1, for g, the x-intercept is 2, and for h, the x-intercept is 3.